Write your seat number in the chat box. येस. बाकीचे मुलं जॉईन होईपर्यंत मला काही सूचना सांगायच्या तुम्हाला मी अनम्यूट केले 2 मिनिटासाठी. तर काही पॅरेंट्स मला फोन करतात, लक्षात घ्या. तुम्हाला अनम्यूट केले, अनम्यूट झालेत का बघा जरा. अनम्यूट झालेत का? येस, एनीवन टेल मी. प्रज्वल आहे का? प्रज्वल.
येस सर.
हा, मी आता जे काही 2 मिनिटं जे सांगतो ते ऐकून घ्या.
हो.
हा, काही पॅरेंट्स मला फोन करतायत की सर तुम्ही लेक्चर मध्ये काही लिहून देत नाही. ऐकून घ्या, मला काही गोष्टी क्लिअर करायच्या. बिकॉज सम स्टुडंट्स आर also new, they are shifted from the A division also. So my teaching methodology is different than the other teachers, remember. So whatever the material I have prepared for you, it is a unique material and all over Maharashtra is using this material, remember. सगळ्या महाराष्ट्रामध्ये हे जे पॉवर पॉईंट प्रेझेंटेशन मी तुमच्यासाठी करतोय, सगळे महाराष्ट्रातले शिक्षक हेच वापरते, लक्षात घ्या. म्हणजे एवढं मेहनत करून आम्ही रात्रंदिवस ह्या सगळ्या नोट्स तयार करतोय. आणि जर मुलांचा अटेंडन्स बघितलं तर 100% अटेंडन्स दिसत नाही. आणि तुम्ही लक्षात घ्या, ह्या पॅन्डेमिक कोविड-19च्या सिच्युएशन मध्ये आपल्या बऱ्याचशा पॅरेंट्सला स्ट्रगल करायला लागते, बाहेर जायला लागते, जॉब, काही जणांचे जॉब गेलेले आहेत. तर सांगायचा उद्देश काय आहे की जे मटेरियल मी तुम्हाला दिलेलं आहे ते लेक्चरच्या अगोदर 1 दिवस किंवा 1 तास आधी वाचायचे. आता कोऑर्डिनेशन कंपाऊंडचं मटेरियल देऊन जवळपास मला वाटतं 2 आठवडे मी हे मटेरियल दिलेले. त्याच्यानंतर मागच्या सॅटर्डे संडेला आपण एक्स्ट्रा लेक्चर घेतले नाही, कारण ठाकूर सरांचे लेक्चर आपल्याला मिळणार होते, पण ते ऑन द स्पॉट आपल्याला मिळाले नाही. तर ते एक्स्ट्रा लेक्चर आपण नंतर घेऊया, तो काही इश्यू नाहीये. फक्त सांगायचा उद्देश आहे की एकच आहे की अजून काही मुलांनी अभ्यास सुरू केलेला नाहीये, एक्सरसाइज सोडवत नाहीये. जे मी होमवर्क लेक्चरच्या आपल्या पीपीटीच्या काही मध्ये स्लाइड्स मध्ये होमवर्क दिलेला आहे ते पण सोडवत नाहीये. मग तुम्हाला मार्क कसे मिळणार, लक्षात घ्या. जरी सिलेबस आपण 25% कमी केलेला असला तरी चॅप्टरचं जे वेटेज आहे ते तेवढंच आहे, लक्षात घ्या. काही मुलांचा असा भ्रम आहे की 25% अभ्यासक्रम कमी झालेला आहे, सोपं झालेलं आहे. असं काही झालेलं नाहीये. जरी अभ्यासक्रम कमी झालेला असेल तरी तुम्ही विचार करा, थोडाच अभ्यास कमी झालेला आहे. 25% म्हणजे की काही पानं कमी झालेली आहेत, पण ते डू यू नो, कॅन यू रिकॉल, कॅन यू थिंक, हा भागावर प्रश्न येणार नाहीये, लक्षात घ्या. म्हणजे काही मुलांच्या डोक्यामध्ये अशी संकल्पना आहे की ह्या वर्षीच सगळंच खूप सुरू होणार नाहीये, पेपर उशिरा होणार आहेत. असं काय होणार नाही. पेपर तुमचे 18 फेब्रुवारीलाच घ्यायचं चाललेलं आहे, लक्षात घ्या. सगळ्या गोष्टी मी क्लिअर करणार आहे आज थोडेसे 1-2 मिनिटं, आणि मग व्हॅलन्स बॉन्ड थेरी सांगून आपण हा चॅप्टर संपूया. कारण CFT क्रिस्टल फील्ड थेरी यावर्षी आपण काढलेली आहे, यावर्षी ती नाहीये. तर रोज काय करायचंय की या नोट्स तुम्ही ज्या मी पाठवलेल्या आहेत आणि जे शिकवलेले ते स्वतःच्या भाषेत एकदा लिहून घ्यायचंय, लिहून काढायचंय. आपण जर प्रत्येक लाईन टू लाईन आणि गोष्ट जर इकडे लिहायला मी सांगितल्या, कारण हे रेकॉर्डिंग पण तुम्हाला मी देणार आहे. सगळे रेकॉर्डिंग, लेक्चर रेकॉर्डिंग होत आहेत. जर काही मुलांना कळलं नसेल, काही मुलं अब्सेंट असतील, तर त्याच्यावरती मी तुम्हाला सांगितलं की त्याच्यावरती काम करणं सुरू आहे. एकदा सगळं शिकून झालं की सगळे रेकॉर्डिंग मी तुम्हाला देणार आहे. पण याचा अर्थ असा नाही की आपण काहीच लिहायचं नाही, वहीच बनवायची नाही, नुसतं जॉईन व्हायचं, असं असले उद्योग करू नका. पॅरेंट्सचे मला फोन येत आहेत, पॅरेंट्स मला फीडबॅक देत आहेत. ह्या गोष्टी सगळ्या लक्षात घ्या आणि कुठंही जायची गरज नाही, लक्षात घ्या. बाहेर जायची गरज नाहीये, कुठलीही ट्युशन लावायची गरज नाहीये. हे जेवढं मटेरियल मी दिलेलं आहे तेवढं तुम्ही व्यवस्थित नीट वाचा. आणि ह्याच्यात जर काही शंका असतील, सर कुठलं परीक्षेला येणार आहे, किती मार्काला येणार आहे, 100 वेळा मला विचारा, मी 100 वेळा सांगतो. पण 100% तुमचं जर अटेंडन्स असेल तर तुम्हाला कळणार आहे या गोष्टी, नाहीतर काही कळणार नाही, लक्षात ठेवा. आता बघा, आपल्या वर्गामध्ये 91 मुले आणि पार्टिसिपेंट 18 आहे. म्हणजे काय यांना व्हॅलन्स बॉन्ड थेरी कळणार आहे? घरी 100 वेळा जरी वाचली तरी व्हॅलन्स बॉन्ड थेरी कळणार नाही, एवढा महत्वाचा मुद्दा आहे तो. तर ठीक आहे, ज्याला शिक्षण घ्यायचंय ते मुलं जॉईन होत आहेत, ज्याला शिकायचंच नाहीये त्याला आपण काही करू शकत नाहीये. ठीक आहे. त्याच्यानंतर आता आपण सुरू करूया, कारण जी मुलं खरंच शिकण्यासाठी जॉईन झालेली त्यांचा वेळ आपण वाया घालवायला नको. So we are discussing about this very, very important concept, valence bond theory, and one question will be there out of these 7 marks with option. 100% one question will be there, either on 2 marks or either on 1 mark. So what is this valence bond theory? There are some postulates, or it is also called as assumptions. Some assumptions are given how the coordination bond is formed between the metal and ligand by this VBT. VBT is one of the theory of bonding, how the bonding takes place. So there are some assumptions, or these are also called as postulates of the valence bond theory, means how actually the bonding takes place. So for the bonding, the two things are very important. One is central metal and the ligand is important. Without the central metal and ligand, coordination compounds are not possible. So what is the duty of the central metal atom? I will explain first. Central metal ion provides vacant d orbitals, remember. So these d orbitals are provided by the central metal ion for the formation of coordinate bonds with the ligands. So we have to remember this thing, whatever the vacant d orbitals are present in the coordination compound, which are provided by the central metal. This is first assumption. Then second one is the vacant d orbitals. See, vacant means these are empty d orbitals, like sp, d and f orbitals are there in 11th standard. We already learned about this, what is mean by orbitals. So these vacant d orbitals along with s and p orbitals of the metal ion takes parts in hybridization. Now this word is very important, hybridization word. So hybridization concept is explained in 11th standard. If you didn't understand the hybridization concept, again you can read it. It is a very easy concept. It is nothing but it is the process of mixing and recasting of atomic orbitals. All these are atomic orbitals. S orbital, p orbital, d orbital, all these orbitals are called as atomic orbitals. So in case of hybridization, what happens? These atomic orbitals undergoes recasting and remixing. Mixing of these orbitals takes place and new hybrid orbitals forms. This is called as hybridization. So in detail it is explained in 11th standard. We can learn in 11th standard textbook, but it is not required. Only in case of valence bond theory we can easily understand this VBT concepts by using some examples I have given. So the third postulate is the number of vacant hybrid orbitals. See, this is a main thing. The number of vacant hybrid orbitals form. Vacant hybrid orbitals form is equal to the number of ligand donor atoms. Means jitne ligands hai. If we take any coordination compound, उस coordination compounds में जितने लिगैंड्स है उतने हाइब्रिड ऑर्बिटल्स फॉर्म होते. So it is written in simple language. Number of vacant hybrid orbitals formed is equal to the ligand donor atoms surrounding to the metal ion, which is equal to the coordination number. So this language is actually complicated. So in simple words, you remember जितने number of ligands हैं, if it is a monodentate ligand, it contains one donor atom. So जितने donor atoms हैं, उतने hybrid orbitals metal ion form करता है. This is the meaning of this third postulate. So we can understand all the postulates if I have taken this one example. So overlapping takes place always when the bonding is there, always overlapping is there. So overlapping takes place in between vacant hybrid orbitals of the metal. See, hybrid orbitals are provided by the metal and filled orbitals of the ligand, because the ligands are already filled, they having the electrons. But the vacant hybrid orbitals will be formed by the metal. Remember this thing. So overlapping takes place between filled orbitals of the ligand and vacant orbitals of the metal. Then next postulate is the hybrid orbitals used by the metal point in the direction of the ligand. Then this is a very important postulate. N minus 1 or ND. I will explain what is this N. This N indicates it is the principal quantum number. Remember, principal quantum number means you know the electronic configuration of atoms. For example, if it is 1s2, 2s2, 2p6, this 1, 2, 3, 4, these number indicates this principal quantum number or energy levels. That is called as N. So in case of this coordination compound, N minus 1d or ND orbitals of the metal, these are involved in the hybridization. These are also called as inner orbital complexes and outer orbital complex. If this N minus 1d is used, if N is 4, 4 minus 1, it will be 3. If the 3d orbitals are used, it is called as inner orbital complex. If ND orbital is used, means here N indicates 4. If 4d orbitals are used, it will be outer orbital complex. All these concepts will be clear when I will take one example. This postulate never it is asked for board exam, remember. So only read the postulates, and by using these postulates we have to discuss the bonding. So for the hybridization, just I explained now, outer orbital complex ND orbitals are used and inner orbital complex N minus D. Inner orbital means 3D orbitals are used. For the outer orbitals, 4D orbitals are used in simple words. Then these are the one chart is shown number of orbitals and types of hybridization. You see, if the coordination number is 4 and types of hybridization is sp3. sp3, here 1s and 3p orbitals are involved. That is called as sp3. sp3 means the shape of the coordination compound is tetrahedral. Again, if the coordination number is 4, there are two possibilities, sp3 and dsp2. Now see, this d is inner orbital, because if d comes first, it is a inner orbital, means n minus 1. N minus 1 d is used here. If d is written first, if d is written after the p, it will be, these are the outer orbitals. Outer orbitals are used. So dsp3, d is the inner orbital. The shape of the molecule is square planar, because the coordination number is 4. These two having the coordination number 4, and this is a trigonal bipyramidal. It is not involved in our syllabus, so neglect it. Then come to the octahedral complexes. Octahedral complexes, they can involve sp3d2. See, here d is from the outer orbitals, and here d is inner orbital. So sp3d2 and d2sp3 is different, remember. sp3d2, it is a In this coordination compound, d orbital is outer d orbital is used, and in this d2sp3 means inner d orbital it is used. This is the difference between this sp3d2 and d2sp3. Though it looks like same, but it is not same. Here sp3d2, here d orbital is used, outer d orbitals are used, and in case of d2sp3, inner d orbitals are used. What is this inner and outer? I will explain with example. So one example is shown here. For example, when hybridization is d2sp3, the structure is octahedral. In case of sp3d2 also it is octahedral. So we have to understand some steps when there is a bonding between metal and ligands. So first one is what we have to do. Find the oxidation state of central metal ion. Then second one, write the valence shell electronic configuration. Then third one, see whether the complex is low spin complex or high spin complexes. Low spin means, just I explained, when inner orbitals are used, the complex is low spin. When the outer orbitals are used, the complex is called as high spin. So this is not asked for the exam, but for the molecule formation, these steps are very important. So fourth step is, from the number of ligands, the number of metal ion orbitals required for the bonding. जितने number of ligands है उतने hybrid orbitals prepare होते, उतने vacant d orbitals metal will provide. Then identify the orbitals of the metal ion available for the hybridization and the type of hybridization involved. Write the electronic configuration after hybridization. All these steps I will. Last one is very important. See, by using these unpaired electrons, we have to predict the magnetic behavior of the complex. If unpaired electron is there, it will be paramagnetic. If there is no any unpaired electron, it will be diamagnetic. So all these steps I will explain with one example. See, I will start now. This example is asked for board exam. All the students concentrate carefully, because out of these examples, one will be for board exam. So octahedral complexes, how to identify this is octahedral complexes? See, 6 ammonia ligands are there. Because they will not give the name of the complexes, we have to identify the complex CONH36 3 plus. 3 plus, it is the charge oxidation state of this cobalt, because this is a neutral ligand. CO3 plus, this is oxidation state of cobalt. This is 6 ammonia. As there is a 6 indicates 6 vacant d orbitals will be provided by this cobalt. So one by one we will discuss. This is a low spin or inner orbital or spin paired complex. There are three different names for this complex. This is low spin. Low spin is also called as inner orbital. Why this is inner orbital? Because inner orbitals are used in this. Inner orbitals are used, and if this inner orbitals are used, it is also called a spin paired complex. So the step number 1 is what? First, oxidation state of the central metal, cobalt. Cobalt is having atomic number is 27, and this is the outermost electronic configuration, 4s2 3d7. Oxidation state is +3. This is in bracket. Outermost electronic configuration is written. As per these steps, find the oxidation state of the central metal ion. So in this case, the oxidation state is +3. And how this +3 is calculated? Because 6 ammonia ligands are neutral. So 6 into 0, it will be 0. So the charge which is on the complex, it will be the charge on central metal atom. So valence shell electronic configuration, it is also shown here, 4s2 3d7. So +3 indicates here 3 electrons we have to remove from this. So cobalt removes 3 electrons, 2 electrons from this S and 1 electron from this 3D. So it will be 3d6. So the diagram is shown here. 1, 2, 3, 4, 5, and 6 electrons are there. This is 3D orbital, this is 4s orbital is empty, and this is 4p orbital is empty. So according to the postulate of valence bond theory, these orbitals, vacant orbitals, vacant d orbitals provided by the metal. These orbitals are provided by the metal. These are ligands are not included in this. So according to the Hund's rule, first single pairing will be takes place, and the 6 electron will be paired here. So 1, 2, 3, 4, 5, they will be paired singly, and the 6 electron will be paired here. First, only single electron will be occupied, and then pairing will be start. 7, if the 7 electron will be there, it will be paired here. Then 8 electron will be paired here. Then the 9 electron will be paired here, and the 10 electron will be paired here. This is according to the Hund's rule of maximum multiplicity in 11th standard chapter atomic structure. We learned about this, how this pairing takes place. But now, how these 6 electrons came? Because the oxidation state is +3, and if cobalt is having +3 oxidation state, means 3 electrons we have to lose. So 2 electron from this 4s and 1 electron from this 3d will be lost. So the number of electrons remaining, these are the 6 electrons will be remain in this orbital. So now ammonia ligands are already given here. Ammonia, how many ammonia ligands are there? There are 6 ammonia ligands are there. So the number of vacant orbitals required should be 6. But here only 1, 2, 3, 4 vacant orbitals are there. Again 2 are required. So जितने number of ligands है उतने hybrid atomic orbitals अपने को चाहिए actually, vacant orbitals. So as 6 ammonia ligands are there, 6 orbitals are required, but there are only 1, 2, 3, 4. So 4 orbitals are needed. So as the complex is low spin, see, as the complex is low spin, so pairing of the electron will take place for the hybridization. For the hybridization purpose, this one electron will be paired here, and this electron will be paired here. So number of see here, see in this diagram. So these 1, 2, 3, 4, 5, 6, 6 orbitals now available for hybridization. जितने number of ligands है उतने hybrid orbitals we required. So the pairing takes place here. This pairing takes place because this is a low spin complex, and in low spin complex, see, n-1 d orbitals are used. In this, what is n? 4. This 4 indicates is n. So 4 minus 1, it will be 3. So 3d orbitals are used for hybridization. So these two d2 sp3. Why it is d2? Because 2 orbitals from d, 1 orbital from 4s, and 3 orbitals from p. So the hybridization will be d2sp3, d2sp3, because 2 3d orbitals, 1 4s orbital, and 3 4p orbitals are available for hybridization. So these are the 6 orbitals are there, 3, 4, 5, 6. So ये 6 atomic orbitals है. अभी तक इसका hybridization नहीं हुआ. So ये atomic orbitals क्या करेंगे? Mix होंगे, recast होंगे, और उतने जितने atomic orbitals हैं उतने hybrid orbitals prepare हो जाएंगे. So atomic orbitals are 6. So automatically the hybridization के बाद जितने hybrid orbitals बनेंगे, that will be 6 hybrid orbitals will be formed. See, these are the hybrid orbitals, d2sp3. d2sp3, how this d2sp3 hybridization? d2, d के 2 orbitals, s का 1 orbital और p का 3 orbitals. ये hybridization उनका हो गया, और 6 hybrid orbitals, now these 6 hybrid orbitals are ready. So ये 6 hybrid orbitals में बिग ओवरलैपिंग किसका होगा? लिगैंड्स का. कितने लिगैंड्स है अपने पास? 6. So 6 ligands के पास कितने इलेक्ट्रॉन है? एक ligand के पास 2 इलेक्ट्रॉन है. 1 ligand having the 2 electrons. So 12 electrons we have to put in this. So in this 2 plus 2, 4 plus 2 is 6 plus 2, 8 plus 2, 10, and 12. So 12 electrons will be from the ligand. So the overlapping takes place between these hybrid orbitals and ligands. It is shown here. So after hybridization, these six atomic orbitals, these are converted into hybrid orbitals. These are the hybrid orbitals. So in these hybrid orbitals, six ammonia ligands are there. So these electrons 1, 2, 3, 4, 5, 6, 7, 8, 9. These electrons came from ligand. Six ammonia ligands having the 12 electrons. All it will be paired, and the hybridization will be D2sp3. This is the complex. As there is no any unpaired electron is there, all the orbitals are filled with electrons. So the complex is diamagnetic complex. Remember, as all the electrons are paired in the complex, it is a diamagnetic, and this is a structure D2sp3. See this 1, 2, 3, 4, 5 ammonia ligands are there, and it is a central metal is cobalt. So Cu NH36 3 plus. This is asked for 2 marks. From this CONH36, we have to write this first valence shell electronic configuration, then oxidation state, then hybrid orbitals, then this structure, and this proper diamagnetic or paramagnetic. This is asked for 3 marks. So one example, it will be asked for 3 marks for the board exam. We will discuss the another example. This example is high spin complexes. This example is low spin complexes. Low spin means here inner d orbitals are used for hybridization, and in the next example, outer d orbitals are used for the hybridization. It is shown here high spin. High spin is also called as outer orbital complex or spin free complex. And opposite to this, low spin complexes, inner orbital complexes, or spin paired complexes. And these names are exactly opposite. So we will discuss here COF6 3 minus. So first step, oxidation state of central metal, you know, it is same as previous one. Atomic number of cobalt is 27. So outermost electronic configuration is 4s2 3d7. It is same. And now see how the oxidation state of this cobalt is +3. I will explain here. So this fluorine fluoride ligands having the -1 charge, remember. So 6 into -1, it will be -6. So, and the total charge on the complex is -3. So -3 when this -6 when these are shifted to the right hand side according to the formula. This formula I have explained again, so I will not explaining again and again. So this -3 plus 6, it will be +3. So the oxidation state of central metal atom or ion cobalt is +3. Then the next step is these steps already explained here. These steps. So after taking the example, these steps will be cleared. That's why I not explain these steps in detail, because all these steps will be completed in the example. So first step is what? We have to write the oxidation state of the central metal. Then second step, valence shell electronic configuration is CO3 plus indicates 3 electrons. Again, we have to lose 2 electron from this S and 1 electron from this 3d orbital we have to lose. So 6 electrons are there. These 6 electrons will be pair. These are the vacant. 4s is vacant, 4p is vacant. But as the complex is high spin, remember, as the complex is high spin, now the inner d orbitals are not used here. So these inner d orbitals will be not used. 4d orbitals we have to use, because the complex is a high spin complex, remember. So as the complex is high spin, means pairing of electron will not take place. Remember, it is purposefully it is shown in bold type. As the complex is high spin, like a previous example, this pairing will be not takes place, because this 3d orbital, it is not used for hybridization. So which d orbital we have to use? 4d orbital we have to use. Here after 4s, 4p, 4d orbital is used. So The 6 orbitals available for the hybridization, these are from the 4D. See, we can clearly see here 2 orbitals we are using from the 4D. We are not using 3D. 3D it is used when the complex is low spin. 4D is used when the complex is high spin. And it is possible. So in valence bond theory, postulates of valence bond theory, it is written Nd orbitals are used for high spin complexes and N-1D orbitals are used for low spin complexes. N-1 means if N is considered as 4, 4 minus 1 is 3. 3D orbitals are used for low spin and 4D hybrid orbitals are used for high spin complex. If we consider this particular example, this is high spin complexes, means in which we have to use this 4D. So 1 4s, 3p, 3p orbitals and 2d orbitals, they undergoes hybridization. And how many hybrid orbitals will be formed? 1 2 3 4 5 6. जितने atomic orbitals hybridization में participate करते हैं, उतने hybrid orbitals hybridization के बाद बनते हैं, which is having the same energy. Remember this thing. In 11th standard, this concept is already explained. What is mean by hybridization? It is very simple. Hybridization में क्या होता है? Atomic orbitals mix होते, recasting होते और नए hybrid orbital बनते हैं. कितने नए hybrid orbital बनते हैं? जितने atomic orbitals हैं उतने ही hybrid orbital बनते हैं. एक भी ज्यादा hybrid orbital नहीं बनता. अभी यहाँ पे देखो, in this example we are using 1 2 3 4 5 6 6 atomic orbitals. ये किसके हैं? सेंट्रल मेटल एटम कोबाल्ट के, ये कोबाल्ट के ऑर्बिटल्स हैं. सो कोबाल्ट के एटॉमिक ऑर्बिटल्स हाइब्रिडाइजेशन इसका होगा. इसके नए हाइब्रिड ऑर्बिटल कितने बनेंगे? 6 हाइब्रिड ऑर्बिटल बनेंगे. और एक 6 हाइब्रिड ऑर्बिटल में इलेक्ट्रॉन्स किसके जाएंगे? ये 6. ये 6 फ्लोरीन है ना, 6 फ्लोरीन having the 12 electrons. So 1 2 3 4 5 6 7 8 9 10 11 12 electrons will be paired, and then the coordinate bond will be formed between this fluorine and cobalt. So this how the high spin complex is formed. It is shown here. So the hybridization will be sp3d2, not d2sp3. Remember, not d2sp3, because we are not using the orbitals of this 3D. We are using the orbitals of this 4D. So the hybridization is sp3d2. This d2 from 4D. Nd orbital used here. So the structure will be like this. See, the structure of the complex will be like this. CO will be at the center, and these are the 6 fluorine, 1 2 3 4 5 6 fluorine ligands are there, which are surrounded, and this is a 3 minus, it is charge on the complex. So we can see clearly here these electrons which are from the ligands. These 1 2 3 4 5 6 7 8 9 10, and these are the 12. 2 plus 2, 4, 6, 8, 10, and 12. So all these 12 electrons are from the fluorine. And these are the hybrid orbitals, remember, 4s, 4p, 4d. So this is sp3d2 hybridization. And in previous example, it was a d2sp3. It is also octahedral complex. It is also octahedral complex, but that was a low spin complex. This is high spin complex. And see one thing clearly, the complex is octahedral and has 4 unpaired electrons are there. See, we can see here 1 2 3 4. 4 unpaired electrons are there. Due to this 4 unpaired electron, this complex is paramagnetic. Paramagnetic means unpaired electrons are there. And if there is no any unpaired electron, we can see, I will show the previous slide. See this previous example. There is no any unpaired electron. See, एक भी unpaired electron नहीं है. That's why the complex is diamagnetic. So I think you understand what is diamagnetic, what is paramagnetic, what is spin, high spin complexes, what is low spin complexes, how the electronic configuration is written. All these concepts are completed in 11th standard. How to write the electronic configuration, 1s2, 2s2. So now I will take this one example and I will stop here. And this chapter is also completed because this is a tetrahedral complex. See, tetrahedral complex, because 4 ligands are there. So there is no question of high spin and low spin. This octahedral complexes only having the question of high spin and low spin. But in case of tetrahedral complexes and square planar complexes, there is no question of high spin, low spin. Only in case of octahedral complexes, they forms high spin and low spin complexes. So already 2 examples are explained. This is the same example, only it is a NiCl4. It is a 2 minus. NiCl4 2 minus. Oxidation state of nickel, atomic number of nickel, it is already given 28. So it is 4s2 3d8 plus 2. It is why it is plus 2. First step is very important. 4 chlorines, it will be 4 minus, and 4 minus when these are shipped to the right hand side, it will be 4 plus. So minus 2 plus 4, it will be plus 2. So plus 2 indicates 2 electrons we have to lose. These 2 electrons will be lost. So in D, 8 electrons are there. 1, 2, 3, 4, 5, 6, 7, 8. So these 8 electrons from this 3D8, as it is, it comes. As oxidation state is plus 2, 2 electrons are lost. So this is a valential electronic configuration of nickel is 4s2 3d8. But valential electronic configuration of Ni2 plus is only 3d8. So this is also empty. This is also empty. As there are 4 ligands, see 4 chlorines. So 4 orbitals are required. Already the 4 orbitals are there. So 1 s orbital and 3 p orbitals undergoes hybridization, and hybridization will be sp3, and 1, 2, 3, 4. 8 electrons we will get from this chlorine. This overlapping takes place. So see this these are the 4 hybrid orbitals sp3d, and this is a structure of the complex. It is paramagnetic. Why it is a paramagnetic? Because there are 2 unpaired electrons are there. If there is no any unpaired electron, it is diamagnetic. As there are 2 unpaired electrons, it is paramagnetic. So this one example square planar complex we can prepare at your home. This is same. So this chapter is completed here, because this crystal field theory, it is not for your examination. This is a reduced syllabus. So all this crystal field theory, this is not for your examination. On the applications of coordination compounds is for your exam. This is not deleted. So these applications where the coordination compound is used. On Monday, I will explain this, and I will start the chapter number 2, that is solutions chapter.